Welcome back everybody. In this video I am going to cover motion equations. So first of all, what are motion equations and what do they allow us to do? Well, motion equations are a set of equations that essentially allow us to model the motion of an object in one direction. One condition of using them is that the object must be experiencing a constant acceleration. If the object is experiencing a changing acceleration, these equations will not work. The reason for that is the way that these equations are mathematically generated through calculus. It makes the assumption that the acceleration remains constant. So that's the fundamental reason why. In high school physics, you won't get asked to use differential calculus or about questions with a changing acceleration, although you might be asked whether it is applicable in that situation. So it's something to keep in mind. If a question is asking you about whether you can use motion equations and you know that's got a changing acceleration, the answer to that would be no. And one thing I'd like to quickly point out too is that motion equations are also sometimes called SUVAT equations. So SUVAT is a mnemonic that people use to remember the variables in the equations. S for displacement, U for initial velocity, V for final velocity, A for acceleration, and T for time. Whether you call them SUVAT equations or motion equations, it doesn't matter. We're referring to the same thing, a set of 4 equations with 5 variables, which are these. So first of all, our initial velocity and final velocity. Those we measure in meters per second. Initial velocity we denote as U and final velocity as V. Then acceleration, meters per second squared are the SI units. Quite self-explanatory, we use A to denote that. Displacement, S, and that will be in meters, and time in T. Now you can get negatives of initial velocity, final velocity, acceleration, displacement, but time must always be positive. I'll go through a few examples later on, show you why, but essentially it's because initial velocity, final velocity, acceleration, and displacement are all vectors. So it's part of defining a direction. Some of those values must be negative whether you set it one way or one direction or the other as the positive direction. I'll show you that later on. For now, let's focus on the equations. So the first equation, V equals U plus AT. Second equation is S equals UT plus half AT squared. Third equation, S equals U plus V over 2T. And the fourth equation, V squared equals U squared plus 2AS. Now, I'm going to do a separate video on showing how you can logically see where these equations come from. The fourth equation, that has to just be mathematically developed. First three, you'll be able to see where they come from. But yeah, I'll do that later on. Let's put these equations to use and we'll try practicing them so you can get a feel for what they're like. So our first question, a rock is dropped off a 50-meter cliff. Determine how long it takes the rock to reach the ground. Before we do anything, we want to define a direction as the positive direction. Doesn't matter which way you do it, but for the purpose of this question, I'm going to say take upwards to be the positive direction. Because remember, we're dealing with vectors essentially. So let's say a velocity of 5 meters per second upwards and 5 meters per second downwards are two different things, and we need to distinguish between them. That is what our direction is going to take into account. Then what I want to do in this question is I want to write down all of the information that the worded question gives us. I'm going to assume that the rock is being dropped on Earth, so it's going to have an acceleration of 9.8 meters per second downwards. As I have defined upwards to be the positive direction, our acceleration will be negative 9.8 meters per second squared. Displacement, that's downwards, so it'll be negative 50 meters. The rock is dropped, so what that means for our initial velocity, it'll mean that our initial velocity will be 0 meters per second. So let's think about what equations we can use that have an acceleration, displacement, initial velocity, and we're trying to work out time. So A, S, U, and T. Turns out we can use S equals UT plus half AT squared. So first thing you'd want to do is substitute the values in. You could try rearranging it first, but then you'll get a quadratic. And as you'll see, in this particular case, you don't need to solve the quadratic because the UT component goes away with a U of 0. Sometimes you do need to solve the quadratic when the initial velocity is not 0. But for the purpose of this, I'm just going to substitute the values in. And then we get t squared equals 10.2. T is going to be the root of that, which is 3.19 seconds. Given that we have been given a worded question, we should supply a worded answer. So in response to this question, I am going to say it will take 3.19 seconds to reach the ground. Okay, second question. A pebble is tossed down a well and takes 8 seconds to reach the bottom. Calculate the depth of the well. So once again, the first thing that we're going to do is define a positive and a negative direction. So once again, I'm just going to say take upwards to be the positive direction. What do we know? Once again, our acceleration will be negative 9.8 meters per second squared. The pebble is tossed down the well. We can assume that it's going to have no initial vertical velocity. It might have an initial horizontal velocity. Haven't gone into projectile motion yet, do that in a later video. But one thing I will tell you about that now is you can treat the horizontal and vertical directions separately. So we only care about the vertical direction here. Any horizontal movement is not going to impact the vertical movement of the pebble. So our initial displacement will be 0. Time will be 8 seconds. We get given that straight away too. So we're trying to calculate the depth of the well. We can find that by finding a displacement. So, like before, we can use S equals UT plus half AT squared. Here we can just substitute our values in, and we get a displacement to be a negative value. Do we want a negative value? Does that mean we've made a mistake, or is that what we've been expecting? Well, we're calculating the displacement. We're trying to find the depth of a well, but what we have calculated is the displacement of the pebble from the top of the well to the bottom of the well. Given we've defined upwards to be the positive direction, yes, we would be expecting a negative displacement. So that's good. But what we should do is interpret that negative and say that's going to be 313.6 meters downwards. And then for a worded answer, the well is 313.6 meters deep. Okay, a bicycle rider is accelerating at 2 meters per second from west for 15 seconds. What is the final speed of the bike? So here you don't really need to say it explicitly in these sorts of questions because it's not like an up and down, it's just a forwards, and we can assume that forwards is going to be, the direction you're starting is going to be the positive direction. But for the purpose of consistency, if you have questions, I am going to make a statement, take forwards to be the positive direction. The acceleration will be 2 meters per second squared. We are given that. We know that the rider is accelerating from west, so the initial velocity will be 0 meters per second. And we get given a time of 15 seconds. So have a look at your equations. We're trying to find something which relates A, U, T, and we're trying to find the final speed, so that will be V. So V, U, A, and T. We can use V equals U plus AT. So substitute the values in, and then we get a final velocity of 30 meters per second. If we're saying, okay, if the question was to ask you for a velocity, you should say 30 meters per second forwards. The question is asking us for a final speed, so all we need to say is 30 meters per second. Okay, question 4. A train experiences constant acceleration over a 2-minute interval. It has an initial speed of 10 meters per second and a final speed of 30 meters per second. Determine how far the train has travelled over this interval of time. As I was saying in the previous question, for a forwards backwards question, you don't really need to explicitly say what you're assuming to be the positive and negative direction. When it is upwards and downwards, you should, but you don't need to if it's forwards and backwards, if it's clear what's going on. But yeah, for the purpose of simplicity, for the purpose of being consistent, I've included the statement anyway. So the initial velocity, we get that from the question as 10 meters per second. Final velocity, we get given, that's 30 meters per second. Oh, I have made an error. Ignore the squared, it's 30 meters per second. Then the elapsed time, that is going to be, we have a 2-minute interval. Are we going to say 2? No, we're not. Remember our SI units, and we need to be in our SI units for these equations to work. SI units are in seconds. SI unit for time is seconds. So that means our time is going to be 120 seconds. We're trying to find how far the train has travelled. That is a displacement. We can use S equals U plus V over 2 by T. Substitute our values in, and then we get a response. 2,400 meters. So the train is going to travel 2,400 meters. Now, as you can see, even I made an error with my units, with my velocity. When you're giving your response, please double check your units. Make sure that your units are correct. And also, if you get an answer which seems ridiculous, like let's say the train travels 20 centimeters over a 2-minute interval, then make sure you check your maths again. It's very unlikely that in an exam they're going to give you a question whereby the answer doesn't make sense for the given context. So, okay, in conclusion, motion equations can be used to model the motion of objects when they are experiencing a constant acceleration. When they're not experiencing a constant acceleration, we can't use these equations. And of course, ensure that you're working in SI units, as we have seen with that last question. And also, once again, if you get an answer that doesn't seem right, then check to make sure that you have computed everything correctly. Only other thing I'm going to quickly say is, as I have been trying to drill into you over the course of this video, if it's a question where, let's say, we're dropping a pebble or we're shooting something up into the sky, you should define a positive and a negative direction. Okay, I'm like make an explicit statement. That's not as necessary if it's forwards and backwards though. Anyway, what I'm going to do is in my next video, I am going to show you how equations 1 through to 3 can be intuitively developed. And then equation 4, that's going to be mathematically derived. I shouldn't say derived, calculated. English terminology. So yeah, I'll show you how the motion equations, they can be developed just so you can build up an understanding of where they come from. I find, me personally, I like to understand where stuff comes from. Helps me to build an intuition up for it. And I hope that would be a beneficial resource to you. So see you in my next video. Show you how to come up with these motion equations. Thanks for watching, and please feel free to subscribe.